I know you guys want to test yourself, don't you?
No.
You know,
What if we're not good test takers? Yeah.
then you're not gonna make it through college. If you're not a good test taker, then pick a field that. Oh, it's recording. I'm here talking nonsense. Okay, so, all right, guys, you gotta look forward to the test. Change your attitude to the test. Doesn't that make sense? Change your attitude towards the test so that you look forward to taking the test. You know, same thing. If you look forward to running, think about that for a second. But why? Is it because you don't like competing?
No, it's just I don't like running. I go to the gym and they make us run, and I'm like,
All right, change the attitude. Figure it out. It's make believe.
it's true.
It's the same. It's same thing with food. Like you don't like a food, it's mental. It's mental. You just do it. Same thing with sleeping on the floor. All right, guys. Why is a x to 0 equal to 1? So one of the easiest ways I can go about this, and then this is a demonstration. It's not really a good proof. There's a really nice proof in abstract algebra, but I can't remember it. So let's just do something simple. Like let's say you take x to the, let me change the color. And let me zoom in. So let's say it's x to the 5th, right? Now, let's start earlier. Let's start x to the 4th. What does x to the 4th mean? Oh yeah, let me zoom in for you guys. That's really small. So x to the 4th, I hope you can see that. You want me to turn off the lights?
Yeah.
Guys, I am here to help you increase your math skills. Trust me, if you put in the effort, you will be completely, but if you put in effort these next 8 months, and even if you're not getting a perfect A, but you're getting like a real C, legit C, your math skills would have improved dramatically by the end of the year, and it's worth it. It really is. That version of you that's better at math is not any better than your current version. They're just going to have different options. You're going to feel different about your abilities, okay? Remember, everybody starts the same without knowing, and you learn as you put in the effort. Now, you might not be the best, but it's worth it. I think it is. All right, let me write this as x to the 5th divided by x. Would that work? Would that work?
So that's the way of getting to the answer.
Well, no, well, sort of. But is that true though? Okay, so look. This is x times x times x times x times x divided by x. Wouldn't that cause one of these to cancel out? And wouldn't that be x to the 4th? So what about x to the 3rd? How would you write that?
X squared over x.
How about x to the 4th over x?
Oh, yeah.
Okay. How about x to the 2nd? X to the 3rd over x. How about x to the 1st? Well, how would you write it?
Let's say I want like do x to the 4th and then x to the 2nd.
Okay, could you?
For 3, say for x to 2. X to the power of 4 and x to the power of 2.
But then that would be x to the 2nd, wouldn't it?
Yeah, so the x to the 2nd.
Uh-huh.
Can we do that? Or is it just has to be a number?
No, don't look at it this way. Don't look at this as a problem. Look at it as a demonstration. All right. How would you x to the 1st, continuing this pattern?
X to the
Okay. How about x to the 0? How would you do it? And what's x over x? Yeah, because look, what's 4 minus 1? Isn't it 3? 3 minus 1 is 2 minus 1. 1 minus 1. Wouldn't this equal to 1? That's why x to the 0 is 1. That's a short demonstration of why that's the case. That's a short demonstration. Have you ever seen that? Does that make sense? Any questions, guys? Okay, so what I wanted to show you here is this. So you gotta, this was based off that you remember that if you have, this was based off that you remember that x to the m divided by x to the n equals x to the m minus n. If you don't remember that, then we can't do anything. Fair enough? Questions? All right, so that, I hope you remember that because I like that demonstration. So when I give you this quiz, or I guess you could call it a test because it's long enough to be called a test, you're able to do it. Did anybody use that as a demonstration to answer that? But is it neat? Doesn't it cause you to understand why that's the case? So you'll never forget that x to the 0 is 1. Why? Because the rules make it so. It's because we want to keep mathematical consistency. All right, how about the next one? Number 2. What is that? Square root of 3 times square root of 3. What does that come out to? Which is equal to 3. Let's go to the next one. Square root of 3 times square root of 12. Which equals to? Good. How about the next one? 3 times 2 is 6. 20 times square root of 20 times square root of 5 is square root of 100. And then what happens? Now, guys, this manipulation of square roots, you need to sit down and do it. I will. If some of you are stuck on the square root nonsense, you need to get out of it. Let's look at number 5. Number 5 means what? 3 square root of 3 squared, which means like this, right? 3 times 3 is 9. Square root of 3 times square root of 3. And 9 times 3. So this is easy. How about the next one? We have something looking like that. This is square root of 8 over 2. We're allowed to write it that way. Square root of 4, which is 2. Johanna, you're here, right? You went to NAMI? Okay, so far so good. Let me scroll it up because people won't see it over there. I can make it move with me, but I'll do some extra steps. How about when we add 2 square roots? What should we do? We should try and simplify it, correct? So let's simplify square root of 8. How do we simplify that? Square root of 4 times the square root of 2. How about the next one? And then we have 2 square root of 2. Oh, that sucks. It's not writing. But invisible. All right, so let me see if I change it from invisible ink to visible ink. All right, I'm gonna just erase it. And I'm gonna retry it again. So we have square root of 4 times square root of 2. Oh yeah? How about now?
Nobody.
It disappears. Okay, how about now? How about now? All right, so we'll just restart it. No biggies. No biggies. Who knows why that's happening? It could be just a memory address in the system that's listen to me, work until you die. You get it? Stop being lazy. That's you being an adolescent. You're gonna live only a certain amount of time. Make it worth something. Think about it. It's a miracle you're actually here. Matter has come alive to be conscious. You are wasting your little time. No wonder you find no value in yourself. Wait, I'm moving that. That's not good. Wait. Look at this. Okay, it's glitching. All right. Guys, next time, when somebody comes to ask something, everybody stand up and turn your back. And then when you guys do that, I'll look at him, I'll be like. All right, so let's wait. But don't do it to the administrator, okay? All right. Once I did that and the kid actually got angry, I'm like, all right, square root of 8. Let's hope it writes though. If it doesn't write, I don't know what to do. Square root of 4 times square root of 2 plus square root of 9 times square root of 2, right? Hey, look at that, it works. 2 square root of 2 plus 3 square root of 2. So that's 5 square root of 2. Yay! Let's do the next one. Square root of 16 times square root of 2 minus 4. It's the same little game. Again, you should know your timetables. If you don't know your timetables, know them. Figure it out. So 4, yes. For which one? What's the square root of 4? Which 2? Okay, so it stays there. Okay, oh, I see what you're saying. So watch. So are you good here?
Yeah.
You understand this part?
Yeah.
All right, so what does 2 times the square root of 2 mean? It means this. Doesn't 2 times the square root of 2 mean that? What is that? What is multiplication? Isn't multiplication repeated addition? I'll give you another example. Isn't 5 times 3 really going to be 5 plus 5 plus 5?
Yeah.
So 2 times the square root of 2 is just square root of 2 plus square root of 2.
Oh.
And wouldn't 3 square root of 2 be square root of 2 plus square root of 2 plus square root of 2? And when you put them together, wouldn't you have 5 square root of 2's?
Yeah.
That's it. So we're working on the next one, same principles. All right, make sense? I'm trying to be as thorough as possible. Again, for a lot of you, this might be, why is he going so slow? Damn it. It is what it is, guys. I'm trying to make sure everybody, you know, just get ready for the quiz. All right, so here I would do this, which becomes this. Oh, you can't see it because I'm at the top. Look what I did there. So now you can go ahead and reduce that That's 4 over the square root of 1/6. Well, that's really 4 square root of 1 divided by square root of 6. Well, that's 4 times 1 divided by square root of 6. That's 4 divided by square root of 6. Do we like having radicals in our denominator? No, so we must rationalize by multiplying both the numerator and denominator by square root of 6. All we did here is essentially multiply by 1. Square root of 6 divided by square root of 6 is 1. But by multiplying by square root of 6, both numerator and denominator, we didn't change the value of it. We just changed how it looks. And we end up writing as 4 square root of 6 over the square root of 36, which is 4 square root of 6 over 6, which is 2 square root of 6 over 3. And you're done. The next one is 12 divided by square root of 3. That's just rationalize. Just rationalize. 12 square root of 3 divided by square root of 9. So that's 12 square root of 3 divided by 3, which is 4 square root of 3. And remember, what one idiot can do, so can another. Put effort into this. You gotta put an hour a day into this class at least. And you will see your skills improve exponentially after a few months. Up to a limit, of course. X to the second times x to the third. There's nothing to talk about there. It's x to the fifth. Does everybody realize that x to the m times x to the n must equal x to the m plus n? Agreed? This one, therefore, is, and I think you can see it, that's a to the 14. Easy questions. Easy questions to get. Okay, you can't manipulate those square roots. Study it, figure it out. Once you start seeing the pattern, once you start putting facts in it on multiple days, it starts sticking there. The next one. B to the fourth raised to the second. Well, that takes advantage of this rule here, where you have something in parentheses raised to another power. It's just you multiply the powers now. So this is just going to be b to the eighth. That's it. Same rule is being applied to the next one. Same rule. And my Microsoft whiteboard just ceased. Give it a second. Maybe it's, I know what's happening. Okay, okay, there. This is x to the, let me zoom in. It's okay. Let me go ahead. I'm going to close out my Microsoft. I shouldn't close it right now. Let me stop the share for a second. There's something weird happened on my side. So stop the share on this here.
Would be the white one.
No, I think in this case, it's what's happened is I have a lot of windows open. And even though this computer's decently robust, it's finished converting the previous video at the same time. And so what I'm doing now is I closed out the whiteboard, and I'm going to go ahead and reopen it. And hopefully, let me close it out again. Then hopefully it refreshes with everything that's on there. Because what happened was there was a momentary, it just erased everything, and that's not cool. Yeah, it just erased everything. Like nothing survived that I wanted to survive. No, I see where it is. It's in the background. So what happened was the weirdest thing just happened, which is ruining my lesson right now. Now everything is going to be here. So what happened was that for some reason, everything I wrote went to the background, but whatever, it doesn't matter. It is what it is. There's nothing to do about it right now. So we are on 14. So that was weird. So I made everything worse. So number 14, it's x to the 6th, y to the 4th. Agree? And then the next one is, well, when we have division like this, remember it's x to the m divided by x to the n. I don't know if you can see it. Yes, you can. So you can write this as 12h to the 12 divided by 4h to the second. That helps out a little bit just to see it. 3h to the 10. Okay. So far, that's most of what we did there. So let me zoom out a little bit. I don't know why I did that, but again, that's an issue with the software. Yeah, now it's dragging everywhere. Who knows how to, I can't even zoom out now. Look what's done. Whatever. All right. Let me zoom down. That happened to have happened when the other video finished the conversion. It seemed like something weird happened there. Who knows? So let's continue. So now, and I forgot to go back to the Zoom and record this. So that'll be something that's missing. Technology. Where's my Zoom? Where's my Zoom? Zoom, Zoom, Zoom. All right, good. Return to meeting. So it's still recording though. Share. Microsoft Whiteboard. Share. Okay, so let's continue. What does this mean here? Well, let me zoom in a little bit more because I don't think you guys can see it up there. A bazillion times. And because of the running, because before I ran on Saturday, I decided to do squats before the run, leg extensions, leg curls, calf raises, add back extensions. I got all that in. So it went an hour wait, and then I ran 10 miles.
So basically, every time you stand up the leg,
It hurts. And
how long did it take?
about an hour and a half.
You ran 10 miles in an hour?
And a half. Well, I don't know. I could do better, can't I?
I thought you said you ran 15.
I was going a little bit over, like I'm 9 miles a minute, 9 minute miles, more or less, 9 to 10. Not too fast, but okay. The point, no, I could have done 15. I decided not to do it because for what, bro? That's the most I've ever ran, huh?
Do you run consecutive or do you do power walk?
No, I don't stop. That's for girls and some guys.
I have to stop in the 30 minutes. 20 minutes.
All right, let's go ahead and 3 to the 3rd, m to the 12, n to the 6 times 2 to the 2nd, m to the 2nd, n to the 4th. Okay, I'll zoom in. Don't worry, I'll zoom in. Yeah, it's kind of small.
Yeah.
Is that better? Okay. I'm getting this drip of my sinuses on my throat. Que jodera. So 27 m to the 12, n to the 6, times 4 m to the second n to the 4. (27) times 4 is 108. Right? M to the 12 times m to the second, m to the 14. N to the 6 times n to the 4th, n to the, oh my gosh. It's finicky. The software is sometimes finicky. N to the 10. Easy? Let's continue. 2 to the negative third, that's just 1 over 2 to the third, which is 1 over 8. Now remember what negative powers are. Negative powers are just the same power, but in the denominator. So remember, if you have 1 over 5 to the second, that's 1 over 25, but it could have been written as 5 over to 5 to the negative second. That's all negative powers are. They're not negative values. They could, you can't, I mean, you have negative exponents, but that doesn't mean it's a negative value. You could have put a negative in front of it and made it a negative value, so don't confuse that. How about 25 to the half? What does that mean? What does a half power mean? It means square root. Square root. So number 19, this would be the square root of 1/4 then. Or in other words, if you don't want to skip steps, this would mean 1 to the half divided by 4 to the half, which is the square root of 1 over the square root of 4, which is 1 over 2. Right? Is it that difficult, guys? Or is it pretty straightforward? Look at the next one. This will be d to the 2/3 divided by d to the 2/3. So that's d to the 2/3 divided by d to the 2/3. That's d to the 0, which is 1, because 2/3 minus 2/3 is 0. X to the m times x to the n is x to the m plus n. X to the m divided by x to the n is x to the m minus n. That's the next group of questions. X to the m to the n, right? X to the m to the n, that's x to the m times n. X to the m divided by n is the nth root of x to the m. And make sure you, and then x to the negative m over n is 1 over x to the m n, which equals 1 over the nth root of x to the m. And those are the basic rules. And that would be what I would refer to as quiz on chapter 2, which will actually be a basics test of your basic skills of chapter 2 stuff. Right? Which I think is important. Because if you don't know those basic manipulations, then what happens when you do a problem that involves some other concept, you might get stuck on just manipulating something. Like the other day, when we're at square root of whatever it was, 6 times whatever it was, all it was to make it look pretty was manipulation. If your manipulation is not strong, you can't do that. Again, guys, don't make up the excuse that you're not good at math, please. Don't believe that for 1 second. It's not true. You just haven't put in enough time to get to where you need to get to. Okay, so now we can look at chapter 3 basics. Now, it took me explaining to you guys that it took me a little bit over 40 minutes. But when you take that quiz, it doesn't take long to take the quiz. Very quick. In about 15 minutes, you should be able to take that test. And that's too much time. So be ready for that, not next class, but the class after. So on Friday. On Friday, you're going to be taking the ones on chapter 2 and one on chapter 3. Then next week, you'll take one on quadratics. Okay? So let's take a look at this here, chapter 3 basics. And what quadrant is the coordinate -3, -4 located? So what will you say? Okay, let me zoom in up there. And what quadrant would that coordinate be? So let's go through it together. It is the third quadrant. So if you take your Cartesian plane, like so, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Now the x and y here would be positive. Here the x would be negative and the y would be positive. Here the x and y would be negative, and here x is positive, y is negative. So in this case, this here would be quadrant 3. Now, what do we label the horizontal axis? What letter do we use? We use the, give me 1 second, because that did that. We use X. We use X. Now, what is a rational number? What is a rational number? Oh, you can't see it. What did that move from there? Did that move on its own? But that's something called OIC. What is a rational number? Very simple. Anything that you can write as a fraction is a rational number. Anything you write as a fraction. So look, is 4 a rational number? Why did it do that? This is making me, no, it's not making me anything. I'm not going to allow this to make me angry. It is just things that you have to deal with. All right. So what is a rational number? Is the number 4 a rational number? Why? You can make it into a fraction. How about 4/3? That's a fraction. This is 4/1. Okay. You know, any number you could write as a fraction is a rational number. Period. An irrational number cannot be represented as a fraction. Okay. Look, a rational number, is this gonna go forever? 1/3? It's infinite, but it has a repeating pattern. Rational numbers have, all rational numbers, if I write 4, here's the pattern. Okay? It repeats 0 forever and it has a pattern. But when you do irrational numbers, it repeats for it goes on forever, but there's no repeating pattern. That's why we can't write it as a fraction. Okay, and yes, be careful. So, questions or concerns on that? All right. So the next question says just substitute the 2 in the x. So you got f to the, I did it again, man. This is not working for me today. I did it again. I don't know why I did that. F to the 2 equals 2 to the second plus 4 times 2 plus 3. You guys can tell that that's easy to do. That's 4 plus 8 plus 3. 4 plus 8 plus 3. That's 15. The next one is f to the half. F of half, sorry, is half squared plus 4 times half plus 3, which is 1/4 plus 2 plus 3. Oh, you should be able to write this as a fraction if you had to. You could say this is 5 1/4. Look, it did it again. To me, it did it again. On your side, it's not showing, but on my side, it just zooms out. So this comes out to the moment my palm touches the pad, it does that. So this is 5 1/4 if you want, or you could write it as 21/4. And then the next one, it says f of positive or -3. It's just two of them. Just you do 3. And you can also do -3. Now notice how I put the parentheses around the first term there, x squared, to emphasize the multiplication and squaring. So it's 9 plus 12 plus 3. 9. It did it again. Yeah, but I should have brought my camera. I bought a 4K camera. 9 plus 12 plus 3. But here, this other one will be 9 minus 12 plus 3. Notice that -3 times -3 was 9. 4 times -3 was -12. And that's why you had to be careful with the signs, because you get two different answers. 9 plus 12 is 21 plus 3 is what? 24. And then this other one comes out to what? 9 minus 12 is -3. -3 plus 3. 0. Agreed? All right. So far, so good. Says for number 5, and let me scroll down because I think it's a little bit. Why did it do that? All right, so we're here. We're getting closer and closer to finishing this particular quiz. And yeah, it's going to be almost identical. We're just going to change what I ask you, just to make it fair. So look at A, find a domain. The domain stands for the allowable values of X. So what are the allowable values for square roots? Can a square root be a 0? Yes. Can it be a negative? No, cannot. But now this square root is in the denominator. Can we divide by 0? No. So you can't divide by 0. 1 divided by 0 is undefined. It's a no-no. It's a big no-no. So in this case, our domain is it's not writing again. Wonderful. All right, it's a bug. There's nothing you can do about it. There's a bug. All right, I'm gonna go ahead and start the application again. There's nothing you can do about it. So I'm gonna stop the share. Okay, fine. Then we go ahead back to the application, start it up again. All right, it started up again. Go back to Zoom for a second. Return to the meeting. Share the whiteboard. I don't know why it does that, but it's acting up today. So who knows? All right, so in this case, the domain will be x greater than 0. It's not writing again. All right, so now I'm gonna stop it from up there. Maybe it's up there. I finished building that pool last week. Getting some inspections done today. Here's my daughter sleeping in class. That's my first baby born. Premature stuff. It should be done with that pool in a month. No, this is not my house. This is the customer's house. I built pool. I don't have home. That's my daughter with the. That's something I had to do to make sure we pass final inspections. That there, 10 miles. That's what I do. And that's it. I'll tell you, right? I mean, which is so much of my youth, man. Anyways. Okay, so let's take a look at B. B again, we can't have a zero in the denominator, and it has to be positive. So what we have to analyze here is we have to analyze. I'm not even on the same question, aren't I?
Why are we on 8?
Yeah. We'll get there somehow. So we did A. A was x greater than 0. We couldn't have it equal to 0 because if so, then it wouldn't work. But now we can't. For B, we can't have 0, and it has to be positive, right? Because it's high square root. So we just say, okay, let's solve this. Whatever this is, that's our domain. So x must be greater than 2. So the domain here is x must be greater than 2. Does that make sense? If you put in 2 in there, it won't work. But anything bigger than 2, it's going to be positive, and it'll work. Okay. Okay, let's do the next one. So, I mean, you can't have 0 in the denominator. Can you ever have 0 in the denominator there? Like, could you ever make that square root negative, like a negative number? Like, square root of 2 is whatever is positive. Square root of 1 is, square root of 0. The smallest you can make that square root is 0. Can you have 0 there? And that in that square, yeah, you can. Because if you made x 0, you have 1 plus 0, you still have 1. So in this case, our domain is just greater than or equal to 0. Notice how that's different than A. If you look at A and look at C, in this case, you could have included 0, but in A, you couldn't have included 0. Does that make sense? It should be clear. Look at D. What values can I not have in the denominator there? You can't have a 0 in the denominator, but when does that happen? When x is a 1 or a 2. When x equals 1 or 2, you can't have it. So what's your domain? Your domain is all reals except 1 and 2. Some people might want to write negative infinity to 1. Domain all reals except 1 and 2. So some people might want to write negative infinity to 1. And so now in theory, there's a few things that are happening here. You could say union 1 to 2, you should 2 to infinity. But let's not even worry about that because the book doesn't even care about this. All numbers except 1 or 2. The last one, how would we do that? What's the domain there? X must be what? Less than 0. Because in this case, if we put a negative value, it becomes positive. You're correct. It can be 0 because 0 is allowed. Okay. So I know we're not done though. Are we? Oh, of course not, because that would be awesome. So now we go to the second part of this quiz. Now, guys, graphing this, I mean, there's not enough space in the quiz, but I should be able to see the following. If I ask you to graph this, I should be able to see you do this. For 0, 0. For 1, it's 6. For -1, it's 6. For 2, what's 2 to the 6th power? Isn't it 64? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. That's 2 to the 4th. 16 times 2 is 32. That's 2 to the 5th. 2 to the 6th is 32 times 2, which is 64. So it's all the way up there. So it's a really narrow parabola. Now here it's not as narrow. In between here, it gets a little bit fatter, but whatever. Well, I can't even do it because it's all the way up here. So 2 to the 6 is 64. It's that simple. I can't see it either because I didn't graph it. I'm just kind of making a quick sketch. I'm just making a quick sketch. All right. How about the next one here on the right? I think that would be just, it says x to the -1/2. So in reality, this is 1 over x to the 1/2, which is 1 over the square root of x. Only be careful. Oh man, they moved it. Don't move it. There we go. But why does it do that? This is finicky. I should lock all those drawings in place. Whatever. All right, I'm just trying my best. I'm trying to be a teacher. All right, can I have 0 for x there? Can I have 0? No. Can I have negative values? Can I have negative x's there? And that's square root? No. So nothing's happening over here. Nada's happening over here. How about if I put 1? What do you get? 1 you get? 1. How about 4? If you put 4, what do you get? Half. How about 9? You get 1/3. So it's doing that. How about if you put 1/4? I'm picking nice numbers, right? If I go 1 divided by 1/4, which is 1 divided by the square root of 1 divided by the square root of 4, which is 1 divided by 1 over 2, which is 2. So if I come here and I zoom, oh no. Why isn't it zooming? But I'm gonna hold on. Whoa, why? No. What happens is for 1/4, which is it's 1/4. It's like it will be here. It went up here. And so you can imagine this doing this. That's what you can do. what I recommend for many of you here is you have your notes. I'm doing in class. I would print this out when I get home, empty, and I would start doing it. And see if I can put it together. So now let's go to, and these are basic skills, by the way. These are skills that we should have. So now we want to find a range. The range is trickier. There's not too many ways, methods you can use to do it. But obviously, here in this case, you could tell that the vertex here, this is a parabola, is -2, -1. It's facing up. So you know that the range, the allowable y values must be y is greater than or equal to -1. Because you realize that if you were to graph this, here would be the vertex, and then it would face upwards. So the y's are from here up. But you would have to know that, you know? You would have to know that, or you would have to make a table and see what the values are doing. B, looks something like this. It's a line. So the range here is like, it's all reals. Because there's no restriction there. Your y values can be whatever you want them to be. The next one is a parabola. Oh my gosh. Oh my gosh, even worse now. Mine. It's incredible. I don't know why it's doing that. This should know I'm left-handed. It should know my palm. You know, it shouldn't be doing that. But whatever. It is what it is. There's nothing to do about it. Let me see. Let me go to, yeah, whatever. I don't care. Let's move on. This is not time for me to figure this out. All right. So here we go. This one's good. Maybe it's the pen. It's the pen. Because there's this button on it. And if I touch that button, it's freaking out. So let's try this again. I'm not going to touch you, button. Don't touch the button. Now, because I'm saying that, I'm going to end up touching the button. I'm trying not to touch the button. So I'm going to hold it like this then. So here we have this. It's going to be a parabola. Let's call this 5. This is 5. All right. It's going to look like this. It's going to be a slightly narrower parabola. Again, if you don't know how things look, then you have to do like a table. All right. And you could tell that the range here is going to be y greater than or equal to 5. And then here in the next one, I mean, again, this is like still 4th power. It goes up, you know. Having a graphing calculator makes it easier. Or not, you got to do a table. And you realize that the range here is going to be y greater than or equal to -1. And that's it. This is how you do this, guys. All right. So now comes the important quiz, the one that I care about the most. When it doesn't disappear. There we go. Chapter 4. Okay. So now if you know this, if you know what you're doing, you can get this done in under 2 hours, you know. This is the important one. Now think about it. Can I move ahead into the rest of this book and you can't even manipulate this for a root? And can you manipulate this for a root? Have to put in some time. A lot of you already like this. So let's go into the quadratics. And again, this is more work for me. This is a lot of work. Let's begin. Please graph y equals 2x squared. Well, you just make a little sketch. And this is 0, 1, it's going to be 2. 2 times 2 is 4 times 2 is 8. It's going to look like this. But here, at this part here, it's a little bit flatter. That's all. It's a parabola that does that. That's it. That's a sketch. It's not the best sketch, but it's a sketch. Okay. So now the next part of this, I talk about, okay, I'll get back to this because I don't have a. So the next part, I say, well, what happens if I have 2x squared minus 2? Well, that minus 2, all it will do is you have the same graph, but now it will be 2 lower. It will look like this. So what that 2 there does, it will cause a vertical shift down 2. That's what it would do. So in general, if you have a quadratic, there's no x in between it, just the squared, and then you just have a constant. The constant, all it does is does this. All right. Now, once you start adding the other stuff to it in between, that x and then the constant, now you start getting a combination of shifting vertically and shifting horizontal. And the way we discover that is, well, let's begin. The standard form is that, and as you manipulate it, you do all that, whatever, who cares? This is the axis of symmetry, show all organizer. Would you please state the vertex? So in this case, we're looking at this part right here. We're looking at this here. So the vertex is going to be, well, 2x minus 5 equals 0. That's going to be x equals to 5 halves. So it'll be 5 half, comma, negative 4. Notice how I found out my vertex. I had to address this here when that equal to 0. When that's equal to 0, I find that x. That's going to be my value for the x value for my vertex. And then whatever's out here on its own, with this value here, that's going to be the... Sí. Por supuesto. ¿Es comida o qué es lo que es? Oh, okay. So that's the vertex. So how about the equation to the line of symmetry? Well, remember, your vertex is in the middle, right, of your parabola. So your line of symmetry will be a vertical line through that x value. So it's just going to be what? X equals to 5 halves. Now it says, hey, convert the quadratic from vertex form to standard form. This is standard form here. So you have y equals 2x minus 5 squared minus 4. So it's 2x minus 5 times 2x minus 5 minus 4, which is, we're going to go ahead and do FOIL. That's 4x squared minus 10x plus 25 minus 4 equals 4x squared minus 20x plus 21. Now, again, some of you are like, why is it going so fast? Because this is something that's like algebra 2, algebra 1. And therefore, you let me know. So, or maybe some of you, if you want to like have some blood flowing through the body, you might want to do this. Scroll up. So I don't have to get up 30 times in class. But it's good because my legs feel better than this morning. I'm gonna stretch out so much. I'm gonna stretch out every day this week. Because I'm gonna run on Wednesday after I do legs, I'm gonna run 3 miles. Then this weekend I'll run 5. But at the end of this month, I'm gonna go ahead and push for like 12 miles. Yeah. Be careful. Okay, so here comes the interesting part because we're almost done with the quiz, by the way. It's not much longer. All right. Now that we wrote this as 4x squared minus 20x plus 21, what's A equal to? 4. What's B equal to? What's C equal to? Ta-da. And then it says here, would you please write down the discriminant? Well, the discriminant is B squared minus 4AC. So let's write it down. It's negative 20 squared minus 4 times 4 times 21. Let's just get a value for it. Right? It's 400 minus, well, 21 times 4 times 4. So I get 64, right? So my discriminant is positive. So it says, how many roots does this quadratic have? How many roots does it have? Well, remember, when b squared minus 4ac is greater than 0, you have 2 real roots. When b squared minus 4ac equals to 0, you have 1 real root, which we refer to as a double root. And when b, and I wrote this b squared, b's of 2, I don't know why I did that. Yeah, there should be a folder or pass up there on the bookshelf. When it's less than 0, we have no real roots, no real solution. So in this case, the answer is it's this guy. It's that guy. It has 2 real roots. Remember, 2 real roots looks like this. 2 real roots has 2 zeros. That's 1 real root or a double root means this. Just touches the x-axis. 1 real root. No real roots looks like this. Doesn't touch the x-axis. So in this case, sketching this situation here for the next letter for G, and you can't see it because I got to scroll up. That situation is going to look, well, you can be precise though. I mean, you know what the vertex is. The vertex was 5 halves negative 4. So let me at least try to make it look pretty. So you know it's and then you know it's gonna do something like this, you know? I don't know, something like that. I mean, that might be wrong. Huh? Oh, so it's narrower. Okay. So let's make it look prettier. 3.5 and what? So it's like really narrow. It might look like something like that, but I guess in the later questions, I'm gonna ask you about that, right? In other words, when we go down, oh my gosh, everything disappeared. Okay, well, where is it? What happened? Oh, there it is. Wait, it's going crazy. Okay, so now we continue. It says, what is or are the x-intercepts? So let me go ahead and go to another portion of this. So what is or are the x-intercepts? Well, let me write down the actual equation. I'm gonna write it in vertex form. So so far we have vertex form and standard form. Y equals 2x minus, what is it? Minus 4 or 5? 5 squared minus 4. That was vertex form. All right, so when we have those y, oh my gosh. Sorry, everything keeps on messing up with this today. When I have multiple things like this, I gotta remember. There has to be a better way. All right, so what I do is I set y equals to 0, right? So 2x minus 5 squared minus 4 equals to 0. 2x minus 5 squared equals to 4. So 2x minus 5 equals plus or minus the square root of 4. So 2x minus 5 equals plus or minus 2. So 2x equals plus or minus.
Hey, for an interruption.
Yes?
Could you please send Johanan Castillo to the main office for early dismissal?
Okay.
Thank you.
Well, so this will be 2x plus 5 equals 5 plus or minus 2. And so x equals 5 plus or minus 2 divided by 2. So you have 5 plus 2, which is 7. Look what it did. If you see what's happening to me, you too, man. So x equals 7 over 2, which is 3.5. Or x equals 3 over 2, which is 1.5. So those are the zeros. And so now it says, what is the y-intercept? Well, the y-intercept is when x equals to 0. Remember, x-intercept is when y equals to 0. Y-intercept is when x equals to 0. So you just put 0 in there. You got y equals 0 minus 5 squared minus 4. So that's 25 minus 4. So that's 21. So the x-intercept is going, the y-intercept is going to be 0, 21. Oh my gosh. If you see what this is doing. 0, 21, right? That's the y-intercept. And the x-intercept, well, those are the zeros. These were going to be 3.5, 0. These are our zeros, and 1.5, 0. So they're separate. Okay. Now Jay says, could you please write down the quadratic formula? And we should know what the quadratic formula is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now it says, would you please set the y value of the quadratic to solve to 0 and solve for using the quadratic formula? So that means, what was our original formula? Y equals to 4x squared, or what was it? 4x squared what? What was the standard form for this? Minus 20x, what else? Plus 21. All right, so a equals what? 4, b equals to negative 20, c equals to 21. So we have negative of negative 20 plus or minus the square root of negative 20 squared minus 4 times 4 times 21 all over 2 times 4. So that's, we already know that this comes out to 20 plus or minus the square root of 64 all over 8, because we already figured out the discriminant earlier in the question, right? And so you have 20 plus or minus 8 divided by 8. So x is either going to equal 28 over 8, or you could say and X equals 20 divided by 8. If you reduce this, you get 7 divided by 2, which is 3.5. And this one's going to be, what's 20? Reduce that for me, please. I can't do it right now. 12 over 8. Oh, is it? What's 12 over 8 reduced to? Okay, wait. What's 28 divided by 8, guys? Right now, my mind's slow. 7 divided by 2. That was fine. And now 20 divided by 8, when you reduce it, is 5 divided by 2. Oh, I see why. Thank you. It's 12. That's why I'm like, what? 12 divided by 8, which is 3 divided by 2. Thank you. Which is 1.5. Isn't that the same answer we got just before? So can we make a nice graph of this? We're almost done. Look at that. I actually had to spend the whole class doing 3 different quizzes. And then to have some of you go next class or the class after, and then I get it off. Because I reserve the right to change what I'm going to give you. If you didn't do this at all, then you need to get on point, please. Could you please, please. I don't know how that happened. It's graph. Well, the great thing is you have 0, 21, so I'm up here right over here. You got these guys here, and you got the vertex here. So you should make a nice graph. Obviously, I'm making an ugly graph, or whatever. You should be able to make a decent graph. All right, nice, because you have the y-intercept, you have the x-intercept, you have the vertex, you have everything you need to make a nice graph. All right, and the last one, which is, I think, one of the more important ones, is the one that you make into vertex form. And so let's do it. Now, unfortunately, the notes today are not going to look as pretty because of the issue that happened. So I might not even post today's notes, but I'll put the video up. Let's go ahead and do vertex form. I'm going to go through it quickly because I want to be done. So y plus 3 equals 2x squared plus 5x. Y plus 3 equals, factor out the 2x squared plus 5 half x. Half of 5 divided by 2 equals 5 divided by 4. 5 divided by 4 squared equals 25 over 16. So I'm going to go ahead and add 25 over 16. Sorry, it zoomed out on me again. Oh no. Okay. I think it might be because the computer is beginning to overheat. I don't know. Maybe I'm wrong. So I'm going to add 25 over 16 here. But if I add 25 over 16 here, I got to add what else? What do I have to add to the other side? 2 times that. So I have to add to the other side 50 over 16 because I had to multiply a 2 out. Now 50 divided by 16 plus 3 is, I'm going to go ahead and just use my calculator and cheat. It gives me y plus 49 over 8. And this guy here can be written as x plus 5/4 squared like this. And then now I just finish it up by saying 2 times x plus 5/4 squared minus 49 over 8. And if I ask you what the vertex is, you would say negative 5/4 negative 49 over 8. Okay. So if I didn't make a mistake, that's good. And everything disappeared. Incredible. All right. Yeah, I think it's just that the process is just getting warm and you know, who knows? So I think that's it for the, that's it, right? Okay. It's freaking out. So let me go ahead and stop the share. Okay, I'm gonna kill Zoom and